Alright, class. This is the practice video for truth tables of given single propositions. This should be completed after you've kind of done your best within reason on after 2.2. So let's go ahead and just work a couple of practice problems. First of all, I cannot emphasize enough, practice is key on truth tables because exam 1 is timed, and if you are insufficiently prepared in terms of actually generating the truth tables and practice, etc., then you're just going to run out of time. So overall, your goal should be to turn this into a procedure. That procedure you follow 100% of the time, and you will get the correct answer 100% of the time. So, more colloquially, your goal should be to be as bored with these things as I am. They're just a simple procedure. They're simple computation if you do it right. So first of all, we have all of the basic logic truth tables now. I'm going to put these at the top of the page. Thanks for nothing, autofocus. But we have the conjunction, we have the disjunction, we have the negation, but 2.2 also added the horseshoe, or curl sometimes, and the triple bar. So in all of these, we're going to do our p by 2 and our q by 1 for the two proposition operators. All right, so again, you need to be able to do these somewhat quickly. So I like to remember what's true of the and, only true when they're both true. Oops. What's true of the or, true except when they're both false. Negation just flips the sign. Horseshoe, I didn't do a video on this yet, but horseshoe, the key to remember is it's only false when if true then false, as we mentioned in Unit 1. So I like, if you have trouble remembering that, I like to think in terms of, well, just remember, what would falsify a horseshoe? Think of any if then. If I study hard, then I will pass. What would show that that was false? Certainly, if you studied hard and you passed, it wouldn't show it was false. Certainly, if you didn't study hard but still passed, it wouldn't show it was false. If you neither studied hard nor passed, it would not show it was false. However, if you did study hard and you did not pass, that would show that if I studied hard, I will pass is false. So I always like to think in terms of what would falsify it, which means in practice, true except if true then false. Remember, triple bar is equivalence. So it's true when they're the same value. So it's true when they're both true or when they're both false. So these are just practice enough with them that you could do them just, that was supposed to be a snap of the fingers, but just so you could do them quickly. The second thing to remember is your order of operations. Don't get creative on me. We do individual atomic statements or propositions. That is your A, B, C, D, etc. Then we do the negations of atomic. Then we do parentheses. Negation of parentheses. Bracket. Negation of bracket. set, negation of set. And again, wherever you can't move on to the next step, you've basically arrived by default at the main operator. So, for individual statements, that's all we're doing now. There's three possibilities. Recall I told you to modify the instructions that if it's impossible that it's false, i.e. Always true, that's called a tautology. If there is no possibility that it's true, that is all false, it's called self-contradictory. And lastly, if it's possible and true and possible that it's false, don't put neither, put contingent. So the one thing I didn't talk about in the last video that I hope was pretty straightforward from the reading is you could also check multiple statements. So two sentences are, again, I'm modifying what's in here a little bit. For this list, it's on the review sheet. Two statements are logically equivalent if they are always the same. So there, if you like to put it in terms of definitions, in terms of possibility, you could say there's no possibility of the two getting a different result. So that's when you're comparing two. They are contradictory if they always get the opposite. So if when you do the truth values everywhere where the first one says true, the second one says false, that's called contradictory. Notice that's between two statements. The last thing you could check for is two or more statements. You could talk about as consistent or inconsistent. So consistent just means possibly all true. Inconsistent means not possibly all true. How do we check that? Is there one line where all statements do true? Is there one or not? So I'm going to flip this over to the next page to give some examples. So I'm not going to work a whole truth table, but suppose the end of truth table 1 is TTFF, and the end of truth table 2 is TTTF. Okay, are those two equivalent? No, because look at line 3. They return a different result. Are those two contradictory? No, because line 1, they yield the same result as they do in line 2 and line 4. Are they consistent? Yes. Lines 1 and line 2 shows it's possible that they're both true at the same time. So you would call these two statements consistent. And again, you could actually do consistent with 2 or more. So if we had 3 and the third one looked like that, they would still be consistent because of line 2. It's possible that they're all true. So again, some of these are not in the textbook. They are on the review sheet, so be aware that you should be able to interpret for consistency as well as equivalence and contradictory. All right, so let's just do a little bit of practice. I would like to do a few truth table problems. And again, I'm going to do start with one on page 50 that is in the back of the textbook. And then we'll do a couple that are not in the back. So, start with exercise group 3, number 4 on page 50. It says F or E implies it is the case that E and F. Notice, I should have said, if it is the case that F or E implies E and F, or if F or E, then E and F. Just, it's good to keep practicing on your translation. Exercise 4 helps with that as well. All right, what do? We don't get creative. Step 1, individual atomic statements. We first have to figure out our N. How many distinct letters do we have? Well, we have an F and we have an E. That's it. So that means we are dealing with a 4-line truth table. I do the halving method, and I say, well, half of 4 is 2. So for E, I'll go by 2's. Sorry, that's an F. For F, I go by 2's for all instances of F, because there is no possibility of F being both true and false. And then I half it, and for E, I'm going by 1's, which means I've done it right, because that's my built-in double check, that if by the time I get to the last letter I am going by 1's, then I've done it correctly. All right. So now that's step 1. We've done atomic statements or atomic propositions, that is your capital letters. Do we have any negations of atomic statements? We do not, so we move on to parentheses. This one is a disjunction. What is true of disjunctions? It is true except false or false. So notice how quickly I can do that now, but feel free to go through a little more slowly and pause as needed. And again, if you want kind of your training wheels on, you can cross those off after with a highlighter. The next one is a conjunction. My fast forward rule for that is true only when they're both true. Which means I can do that rather quickly as well. Again, feel free to go as slow as needed. And again, feel free to highlight. Don't cross off, but highlight if you are worried about that. So, negations of parentheses, nope. Brackets, nope. Which means it is time for the main operator. In this case, it's a horseshoe. It's saying if the value of the first parentheses, then the value of the second parentheses. That is, if this column, then this column. And it's a horseshoe. What's the fast forward rule on the horseshoe? It's true except if true, then false. So, if true, then true, that's line 1 on the horseshoe truth table, is true. If true, then false, is false, line 2 on the true horseshoe. If true, then false, nope. If false, then false, line 4 on the horseshoe. It's like that. So there is your main operator. Again, I like to circle it when I'm done, because then that really forces me. This is what I'm looking at to determine if it's tautologous, self-contradictory, or contingent. Which one applies here? It is consistent. It's possible that it's true and possible that it's false. So I just write consistent here. Sorry, contingent here. Too many C words. To get my full credit. So there's that. Let's do one that's not in the textbook. What if I want to know A and B or C as one statement, and then A or C and B or C as the other? So first of all, if there's instructions on the exam, you might determine whether they are logically equivalent, consistent, contradictory, inconsistent, state all that apply. That's possible. Or I might just ask you if they're logically equivalent, or ask you to show if they're logically equivalent. So again, be sure you know what these words mean so that you're not just plugging numbers that you can interpret correctly. But we'll just crunch the numbers and see what we get. So, first of all, what's our n? Our n, in this case, is 3. There's an a, a b, and a c. Don't get creative. 2 to the third power is 8. So I'm going to go by the halving method. And so first I'm going to go true, 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 true. That is, we're going to go 4 trues and 4 falses for all instances of A, which means I also need to be doing it here because you can't compare apples and oranges. You can't compare a truth table where A is true in one statement and A is false in the other statement. I don't even know what that would mean, so don't do that. Then we're going to half it for all instances of B, so B, all instances of B, will go by 2's. And then half it again for C, and all instances of C will go by 1's. I'm very sure I can tell whether it's a T or an F, please. And I know I've done it right because when I'm on my last letter, I'm going by 1's. Now, what have I done here? This is just step 1. This is individual atomic statements. This is all possibilities for these twos. Then what? Now, people do different approaches with this. You could complete this entire truth table and this entire truth table. I tend to go the other way. I'll do all parentheses in both truth tables. So A and B. This is conjunction, so it's only true when they're both true. True, true, false, 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 false. Again, if you need the highlighter, you're welcome to. If you're into pattern recognition, that can help you sometimes with truth tables. If you haven't messed with anything, if this is your first computation, you should preserve proportion. So one out of when you haven't done anything on the conjunction truth table, 1 out of every 4 is true. We have that here. We have 2 out of 8. Very similarly, when you haven't done anything, you'll see that the disjunctions, 3 out of every 4 are true. So what's the fast forward rule on the disjunction? True when at least 1 is true. So this parenthesis, A or C goes true, 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 false, true, false. Again, take as much time as you want. You don't need to, when you're practicing anyway, you don't need to be as fast as me to succeed on the exam, but you've got to be definitely a little better, a little faster than the kind of thing comparing the truth values. So. Other disjunction is B or C. True or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. All right. No brackets in either one, so it's time for the main operator. In this case, it's a disjunction, disjoining the parentheses or C, that is this column or this column. And if you used your highlighter, you'd see that. So once again, it's a disjunction, so it's true unless they're both false. So true or true is true. True or false is true. False or true is true. False or false is false. False or true is true. False or false is false. False or true is true. False or false is false. Theoretically, done with that, done with that. And there's my main operator. That individual statement you would call contingent, because it's possible that it's true and possible that it's false. That's not surprising, by the way, because, well, for reasons I don't know. Second truth table, the main operator is the conjunction. It is conjoining the value of this parentheses and the value of these parentheses. That is, it's conjoining those two columns, the two disjunctions. And it's a conjunction, so it's only true if they're both true. So true and true is true. True and true is true. True and true is true. True and false is false. True and true is true. False and true is false. True and true is true. False and false is false. There's the main operator for the second statement. So if I was asked to compare those, again, depends on what I'm comparing, but first of all, notice here it's true, here it's true, 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 false, false, true, true, false, false, true, true, false, false. Check every one, because you will run into ones once in a while where they're the same the vast majority of the time, but they might have one line where it's different. In this case, 8 out of 8 are the same, which makes them logically equivalent. Or just equivalent is fine. However, depending on the instructions, you might also have to tell whether they're consistent or inconsistent. That's pretty easy. Is there a line where they're both true? Yes, right there, line 1 proves they are also consistent. By the way, here's a fun conceptual question. You might want to pause and think about it after I state it. Can two statements be logically equivalent and inconsistent? If so, when? The answer is yes, they can. If both statements are self-contradictory, that is, if the main operator, say, is 4f's on the first and 4f's on the second, the main operators look like that, then we would have a case where each individual line is the same, so they're logically equivalent, yet they're inconsistent. Because there's no possibility they're both true. And that's not surprising. If the word consistent actually mimics how we use it in real life. Well, no, it's not a consistent story if it contradicts itself, and it's not a consistent, and anything that contradicts itself can't be consistent with anything else. So, again, the reason I'm asking you those kind of little things is if you can do all the computations, but you can't tell me what they mean, it's meaningless. And you need to be able to convert what's on the truth table to claims about possibility. In this case, all the ones that are listed on the review sheet. That is tautologous, self-contradictory, contingent, logically equivalent, contradictory, consistent, inconsistent. Those are important. You must know those. Otherwise, you're just kind of doing a mindless exercise. Let's go ahead and do one more. We'll do another comparing two statements because that gets you twice the practice. So let's say the first statement is A, if and only if not B and C. Sorry, A, if and only if it is the case that not B and C. And then the second one, we will say B and it is the case that not A and C. So again, make sure to read and follow the instructions carefully, but we'll just talk about all the required terminology that applies. Once more, we have an A, a B, and a C, so we have our N is 3, which means our number of lines is 8. So for completing step 1, for all instances of A, we're going to go by 4s. And I hope you notice here, sometimes people get into trouble because they'll do the first one of this statement by 4s, and the first one of this statement by 4s, even though it's A here and B here. So no, once it's A, has to match. All instances of B will once more go by 2s. biggest challenge here is slowing myself down enough to be legible. And the last, we'll go C by 1s, and so we have that built-in double check that we know we did the right number of lines. Interestingly enough, some people just get stuck on 8 mode, so if I give you one that just has an A and a B, they'll give me 8 lines instead of 4. Don't do that. Alright, negations of atomic statements. Yep, sure do, right there. So, what does the negation do? It just flips the sign. It goes false, false, true, true, false, false, true, true. Marker that if you want to, perfectly optional step. And then we have one here. So A goes by 4s, so not A will go by 4s too. False, 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 true, 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 true. Good times, noodle salad. All right, now, next we go to parentheses. Oh, I'm sorry, yet again. I am so used to a different textbook from last semester. Dots are ampersands. All right, so the main operator of this parenthesis is the conjunction. What is it conjoining? It's not conjoining B and C. It's conjoining not B and C. So this one and this one. So what's my hurry up rule with conjunctions? Only true when both are true. So false and true is false. False and false is false. True and true is true. True and false is false. False and true is false. False and false is false. True and true is true. True and false is false. All right, over here, doing something similar, we're conjoining not A and C. False and true is false. False and false is false. False and true is false. False and false is false. True and true is true. True and false is false. True and true is true. True and false is false. So that is all possible values of the parentheses. Don't have any brackets. Time for the main operator then. The main operator in the first one is an equivalence. It's saying A is equivalent to the value of the parentheses. That is, A is equivalent to this. Well, let's see if it is. What's the hurry up rule for equivalences? True when they're both the same. So true if and only if true is false. True if and only if false is false. True if and only if true is true. True if and only if false is false. False if and only if false is true. False if and only if false is true. False if and only if true is false. False if and only if false is true. There's your main operator. Done, done. And if you were just looking at this individual statement, you would call it contingent, because it's possibly true and possibly false. All right, let's see what happens over here. This main operator is a conjunction. It's conjoining B and the value of these parentheses. What's the hurry up rule with and? Only true when they're both true. So true and false is false. True and false is false. False and false is false. False and false is false. True and true is true. True and false is false. False and true is false. False and false is false. So there's your main operator. This individual one, notice, is also contingent. Why? Because there is one possibility that they're all true. That occurs when B is true, when A is false, and C is true. Right there on line 5. So, are these two equivalent? Let's check. Same, same. Nope, not the same. So they are not equivalent. And if you'd like, you could even write not equivalent for good practice. So when you're talking about both, not equivalent. And but notice the fact that the first one is the same means they're also not contradictory. But lastly, are they consistent? What does that mean? Possible that they're both true. Yes. and there is one and only one line that proves that they are consistent, and that is line 5. All right, that's it for individual, so truth tables for individual propositions and groups of statements. 2-3 will go on to start doing arguments. But you can already see how that's going to go, because anything that can be defined in terms of possibility can be done and determined on a truth table. We can define validity as an argument in which it is impossible for all premises to be true and the conclusion false. And so all we need to do is look if there's such a possibility there. And we will actually find 2 ways of doing that, and we'll do another practice video afterwards. And we'll see you next time.